Ever wondered why the direction of a car is as crucial as its speed when you're navigating through a city? This seemingly simple question leads us to an intriguing part of physics, the world of quantities. When we talk about quantities, we're referring to anything that can be measured. It could be the length of a football field, the weight of an apple, or the time it takes for a hummingbird to flap its wings. But did you know these quantities are not all the same? They fall into two distinct categories, vector and scalar. Scalar quantities are the simple ones. They only have magnitude or size. On the other hand, vector quantities are a bit more complex. They have both magnitude and direction. But why is this distinction important, and how does it impact the way we understand and interact with the world around us? So buckle up as we delve deeper into these two types of quantities and their significant differences. Imagine you're in a race. What matters the most? Your speed, right? Well, in the realm of physics, speed is what we call a scalar quantity. It's a concept that seems simple at first glance, yet its simplicity is what makes it so fundamental to our understanding of the physical world. A scalar quantity, you see, is defined by just one characteristic, its magnitude. In other words, it's all about the size or amount of something. Think of it like this. When you're in that race, you don't just want to run, you want to run fast. Your speed, the how fast, is a scalar quantity. Let's consider a few more examples. The temperature of your morning coffee? That's a scalar quantity. The mass of an apple you're about to eat? Another scalar quantity. Each of these is defined solely by its magnitude. It's how much. So in a nutshell, scalar quantities are all about the how much. Now think about a plane in the sky. Is knowing its speed enough to understand its movement? Here we're stepping into the intriguing world of vector quantities. These are the quantities that require a bit more information than just the how much. They also need the which way. Consider velocity, for instance. It's not merely about speed, but speed in a certain direction. Or think about force. It's not just about the intensity of the push or pull, but also the direction in which it's applied. And then there's displacement, which involves not just the distance, but also the direction of the movement. So you see, vector quantities are like the intriguing plot twists in our physics story. They add an extra layer of complexity, making things a bit more exciting and a bit more real. So vector quantities add an extra layer of complexity, as they're all about the how much and the which way.